everyone. So in today's video, we're going to be talking about motion transformation systems. The video is actually going to be split up into two parts. The first part, we are going to be defining what a motion transformation system is. And then in the second part, we're going to be going through the 4 types of motion transformation systems. And we're going to break this up into which systems are reversible and which systems are not reversible. So let's get started. A motion transformation system is a type of system where the motion changes. Now, the key clue that we have here is the word transform, because transform means to change. So what this means in the system is that my driver component and my driven component do not have the same motion. So I have 2 possibilities here. That my driver component starts with rotational motion and my driven component receives translational motion. So that in between the driver and the driven, there was a transformation that took place. Now, the other option that could happen in a motion transformation system is that my driver starts with translational motion and my driven transforms that motion into rotational motion. Now, to recap what the terminology of driver and driven means, driver is the component that starts our motion. In the motion transformation system, and then the driven is the component that receives the motion at the end. So unlike a motion transmission system where the type of motion is the same throughout the system, in a motion transformation system, the type of motion changes. Now, before we talk about the different motion transformation systems, I want to recap what the word reversibility means. In a motion transmission system or a motion transformation system, if a system is reversible, then that means that the driver component can change positions with the driven component. So what this means is that the driver, again, is the component that starts the motion. The driven is the component that ends or receives the motion. If the system is reversible, then that means that the driver can become the driven and the driven can become the driver. In motion transformation systems, there's only 2 systems that are reversible. And the only 2 systems that are reversible is the rack and pinion system and the slider and crank system. So we're going to start by talking about those systems. So if we're looking at our rack and pinion system, we have 2 key components. We have the rack, which is the bar that undergoes translational motion, and we have the pinion, which is our gear that undergoes rotational motion. As I said before, this is reversible. So that means the rack can start the motion or the pinion can start the motion. Now, there's 2 things that's also really important. The pinion only rotates, so that means the pinion is undergoing rotational motion, and the rack only translates, so that means the rack is undergoing translational motion. So the rack, in this case, went translationally bidirectionally, so that means both ways, and then the pinion rotates bidirectionally. One of the key things with a rack and pinion, because the rack and the pinion both have teeth, so I have teeth on the rack, I have teeth on the pinion, the spacings have to be the same. If the spacings are not the same, then they won't be able to rotate. Where we find rack and pinions, we actually find them in cars. And they're actually involved in steering. that the steering wheel is actually connected to the pinion, and then the two front tires are connected to the rack. And to see a video of our rack and pinion, check out video 2 in this playlist. All right, so our next motion transformation system that is reversible is our slider crank system. Now, our slider is the component that undergoes translational motion, and our crank is the component that undergoes rotational motion. So if we're looking at our setup right here, our slider underwent translational motion, and it is also bidirectionally, and our crank undergoes rotational motion. The system is reversible, so the crank can start the motion, or the slider can start the motion. Key thing, the crank is the component that rotates, the slider is the component that translates. Where we would find slider crank systems, we would actually also find them in cars. We would find them in the pistons found inside our engines, and we would also find these in trains for the wheel components. Because the slider is in a track, one of the things that you have to do here is that it has to actually be lubricated with some sort of oil to reduce the friction. To see an example of a slider crank system, you would check out video 3 in this playlist. Now, our first two systems that we looked at, rack and pinion, slider cranks, those systems are reversible. The next two are not going to be reversible. The first one that we're going to look at is our screw gear system. They are not reversible, so that means in our screw gear system, whatever component is the driver is the only component that can start the motion. It does not, you cannot have the driven start the motion. Now, our screw gear system, there's actually two types. And it depends on which component is the driver in that particular system. So our type 1 system, which is our trusty car jack, is where the screw is the driver. So if we're looking at our video right here, the bar right here, our screw, that is our driver. And the driver is undergoing rotational motion. So as the screw is turning on its axis, it's causing the nut right here to undergo translational motion. So going upwards and downwards. So the nut is the driven. This is not reversible because if I try to move the nut, the screw is not going to rotate. And this is what I meant by you have to be very careful about what reversible is. Reversibility has nothing to do with can it go forwards and backwards. That has nothing to do with reversibility. Reversibility has to do with does the driver and the driven position change in the system. And in a screw gear system, it does not. In our first type of screw gear, which we have in our trusty car jack, so this is a car jack, the motion starts at the screw. So the screw is the driver, undergoes rotational motion. The nut takes that rotational motion and transforms it into translational motion, allowing the jack to rise. Check out video 4 in the playlist where you see a lot of examples of this. The screw, and as I was saying, there's actually two types of screw gear systems. This is the first. The second type of screw gear system is where the nut is the driver. And the key example where we see this, we actually see this in a monkey wrench. So in this case, the nut is the driver and it rotates. And that allows the screw component right here, which is the driven, to undergo translational motion. So it will be going translational motion bidirectionally. The nut, which is our driver, will be undergoing rotational motion bidirectionally. Not reversible. And to see an example of this in action, check out video 5 in our playlist. Our last motion transformation system is our Taman Follower. And our Taman Follower is not reversible. The cam has to be the driver. It is always the driver component and it rotates. And as a result, the follower is the driven and it undergoes translational motion. I hope these helped. Make sure to check out the videos in the playlist. The specific video for the Taman Follower would be video 8 in the playlist. And I hope you have a great day.